In the broad sweep of the history of the idea, spontaneous generation was not enjoying much support at the time that Blumenbach started to develop his conception of the formative drive. Nonetheless, in each of the first two versions of the Bildungstrieb essay, in 1780 and 1781, he appeals to this idea, which he admits is unpopular and embattled as evidence in favor of the existence of the formative drive and against the existence of pre-existing germs. From 1787 on, however, all discussion of spontaneous generation disappears from Blumenbach's writing. What I would like to do in my talk this afternoon is to look into the details of this brief episode and discuss what it means for Blumenbach's conception of the formative drive more generally. A brief sketch of the state of how people understood spontaneous generation in the lead up to the last decades of the 18th century will be useful to contextualize Blumenbach's own contributions to this history. First, it should be noted that what exactly spontaneous generation consists in and how it is both similar to and distinct from the related idea of equivocal generation warrants further comment than is possible here. Since both concepts involve the emergence of some form of life out of a different kind of existence, whether it is from non-living matter in the case of spontaneous generation or from a different species in the case of equivocal generation. And since Blumenbach himself treats the concepts as basically equivalent, I will not distinguish between them and will simply discuss spontaneous generation. The idea that living things arise spontaneously, that is, without being produced by parents of the same species, is ancient. Aristotle argued, for example, that eels are produced by mud and humid soils rather than from other eels, which he took to lack the anatomy necessary for reproduction. It was also broadly accepted that worms emerged spontaneously from rotting flesh. Such views came under heightened scrutiny in the 17th century, and Francesco Rudi designed experiments to establish that worms are generated in rotting flesh only when insects are first able to deposit their eggs upon it. As credence in the spontaneous generation of insects flagged, however, microscopy opened new domains for investigation. Anthony van Leeuwenhoek, for example, discovered microscopic living animalcules and putrid matter using lenses and microscopes of his own creation. The profusion of microscopic life he saw was, on his view, surely generated spontaneously out of the putrid matter he had prepared. In the mid-18th century, John Tuberville Needham and the Comte de Buffon sought to develop a theoretical apparatus to support and explain Leeuwenhoek's insights. Needham proposed a view, popularized by Buffon, according to which all living creatures contain certain organic molecules, which are released upon their death and decomposition. Once released, these organic molecules can combine with others to generate simpler living beings from decayed tissue. Needham set out to demonstrate the truth of this view by enclosing animal and vegetable broths in glass vials stopped up with corks. In time, microscopic life was visible in the vials, and he concluded that they could only have arisen from the decaying animal and vegetable substances in the broths, since the cork would have prevented any supposed pre-existing germs from making their way into the vials. These experiments were met with both speculative and experimental resistance. Charles Bonnet and Lazzaro Spallanzani defended just the interpretation of Needham's experiments his use of corks to plug the vials was supposed to rule out. The animalcules, they claimed, were not the products of spontaneous generation, but of pre-existing germs that had penetrated the porous cork stoppers. Spontaneous generation, therefore, did not exist. To support this interpretation of Needham's experiments, Spallanzani repeated them with vials sealed more effectively and largely confirmed his expectations. Needless to say, however, Needham was not convinced, and there was protracted dispute about how to interpret his observations. It is against this backdrop, which saw an embattled Needham squirming to wriggle free of Spallanzani's experimental refutation of the ideas of organic molecules, vegetative force, and spontaneous generation, that Blumenbach published the first version of his Bildungstrieb essay in 1780. In the first two versions of the essay, Blumenbach defines the formative drive, notes the underlying unity of generation, nutrition, and regeneration, and turns directly to a discussion of generation. Whereas people generally assume that generation is always a matter of parents producing offspring, he writes, quote, there was formerly a time when this means of reproduction was not seen to be absolutely necessary, when it was not assumed that the generation of fleas required other fleas, crabs other crabs, and mice other mice. Rather, it was believed that fleas could be generated by urine and sawdust, crabs by rotten veal, and mice by slime and all manner of filth. This generatio equivoca was once a welcome sanctuary of ignorance and a source and pillar of all imaginable forms of superstition. But it has already been a long time since it has been overthrown, and since then has almost always been cited, like witches' rides and divining rods, as a reminder of that darkness and the quiet triumph of our enlightened times, unquote. Opponents of spontaneous generation have, quote, all too confidently asserted the universality of reproduction by paternal seed, unquote. Thus, one must accept that, quote, sometimes some fluids acquire a formative drive through a special kind of fermentation or putrefaction and bloom into various admittedly simple, or if you will, imperfect kinds of vegetation, unquote. The example Blumenbach cites in support of this claim is a common one in the context of early modern discussions of spontaneous generation: galls. In plants, galls are swellings or abnormal growths on external tissue, often caused by viruses, bacteria, fungi, or insects. Blumenbach focuses specifically on the rose bedeguar gall, which grows on a dog rose when a gall wasp injects its eggs into one of the rose's leaf buds. Galls demonstrate the falsity of pre-existence theories, according to Blumenbach, and vindicate the Bildungstrieb. He writes, quote, I am not afraid, however, that one will find it vulgar to suppose that a formative drive could be stimulated in the excrescent fluid that comes from the insect's sting, which through injury, the eggs laid at the same time in the plant, and other alterations, forms this fluid into a gall, just as after true fertilization, the procreative fluid is organized toward the production of a new animal or plant, through which proper reproduction is effected, unquote. Though previous authors had argued that the insects that emerge from galls were the product of spontaneous generation, Blumenbach's claim is different. The thing generated without a seed is the gall, which is produced through the action of the formative drive on the fluid excreted by the wasp into the stem of the rosebush. It is absurd to think, Blumenbach argues, that rose bushes everywhere are covered with the dormant pre-existent germs of galls simply waiting to be activated by a chance encounter with a wasp. Instead, we should see these growths as effects of the widespread power of the formative drive. Rose galls provide Blumenbach further ammunition against pre-existence theories as well. Albrecht von Haller's observations of the development of chicken eggs were taken by him and many others to establish the pre-existence of the germ of the new chicken in the unfertilized egg. Charles Bonnet was especially taken by the observation that the membrane that encases the yolk of an egg is continuous with the membrane in the embryo's intestines, which suggests an internal rather than a merely external connection between the yolk and the embryo. Bonnet accordingly concludes, quote, the yolk is an essential part of the chicken, but the yolk exists in the unfertilized egg. The chicken therefore exists in the egg before fertilization, unquote. A closer examination of rose galls undermines the idea that the membranes on the surface of the yolk surrounding and connected to the chicken embryo are evidence of the pre-existence of the chicken in the yolk. Like the embryo, the gall is both surrounded by and connected to the woody tissue of the rosebush. But, quote, if one cuts through the middle of fresh rose galls, or galls that have been soaked for a few days, along with the branches they sit on, the transition from the woody vessels of the rosebush to the mossy core of the gall is most visibly displayed, sometimes with an exceptional elegance, unquote. If we can distinguish the tissue of the gall from that of the rose itself, and see how they grew into or became continuous with each other, we need not conclude that the gall pre-existed in the rose just because they are now growing together. Similarly, Bonnet's inference from the continuity of vessels and membranes in embryos and yolks to pre-existence is hasty, since that continuity could just as well be the result of the formation and growth of the embryo, as we see in the rose gall. Though it only occupies a few pages, Blumenbach's revival of the notion of spontaneous generation in the 1780 and 1781 essays on the formative drive is nonetheless a prominent component of his attack on theories of generation that appeal to pre-existent germs. This is not a retrospective judgment, but Blumenbach's own. In the notice concerning the publication of the 1781 version of the Bildungstrieb essay in the Göttingische Anzeigen, Blumenbach highlights the phenomenon of generation without seeds as something his theory can explain and that its competitors cannot. Given this estimation of the importance or novelty of his treatment of the idea of spontaneous generation in the context of his development of the theory of the formative drive, it is not surprising that his other major publication of the early 1780s, the Handbuch der Naturgeschichte, echoes what we have just sketched. In the first, that is 1779 edition of the Handbuch, Blumenbach raises the issue of spontaneous generation in his early discussion of organized bodies in general. After noting how important the microscope has been in discovering the true origins of life the ancients had mistaken for the products of spontaneous generation, he comments, quote, "As embarrassing as it is today, and as little as we are inclined to speak the word generatio equivoca, it appears to us that it seems more often to be laughed at than thoroughly refuted," unquote. He then mentions the difficulty of explaining how certain kinds of worm, which are only ever found in the bodies of other animals, including unborn and only very recently born individuals, arise. The implication, of course, is that these might be instances of spontaneous generation. Though this issue is only briefly addressed in the Handbuch, Blumenbach again takes his cautious words in support of spontaneous generation to be important enough to highlight. In the notice about the volume he wrote for the Göttische Anzeigen in September of 1779, Blumenbach repeats the idea that the doctrine that had been ridiculed, this doctrine had been ridiculed rather than refuted, and notes that the author of the Handbuch simply wants opponents of spontaneous generation to explain the generation of worms in the intestines of unborn animals. When Blumenbach reworked the Handbuch to reflect his rejection of pre-existence theories and his development of the notion of the formative drive, he also expanded the discussion of spontaneous generation. Thus, the second 1782 edition claims, quote, "As little as we allow ourselves to promote the absurdities that scholastic stupidity inferred from this kind of generation, which was once taken to be so adventurously extensive, it seems undeniable to us, however, that one must allow some exceptions to the otherwise so universally accepted generation from paternal seeds, and accept a kind of generatio equivoca, or rather spontanea, without available seeds," unquote. The second edition of the Handbuch, in other words, follows the Bildungstrieb essay of the previous year. In fact, it even substitutes rose galls for the first edition's worms as the favorite example of this kind of generation. In short, in the late 1770s and early 1780s, Blumenbach's major publications present a unified picture of the importance of a qualified notion of spontaneous generation. For both his attack on pre-existence theories of generation and the defense of the formative drive as the cornerstone of his own theory. We see this in the increased confidence with which he presents the connection between the formative drive and spontaneous generation, as well as in the prominence he affords his rehabilitation of the latter in his efforts to promote these works. This was not to last, however. By the time Blumenbach presents new observations on the formative drive to the Royal Society of Göttingen in 1787, discussion of spontaneous generation has fallen away. It is also absent from the 1789 and 1791 Bildungstrieb essays. He keeps the discussion of rose galls as evidence against Haller and Bonnet's claims concerning the pre-existence of the chicken in the yolk, but cuts his argument that spontaneous generation is a phenomenon the formative drive can explain that pre-existence theories cannot. The Handbuch again follows suit. Beginning with the third, that is the 1788 edition, Blumenbach no longer links the formative drive with spontaneous generation. Moreover, the fourth, that is 1791 edition of the Handbuch contains a brief request that readers ignore the, quote, immature 1781 version of the Bildungstriebesse and refer to the more recent 1791 version as authoritative. This raises two questions, one historical and one systematic. The historical question is, of course, what led Blumenbach to back away from this pattern of tying the formative drive to spontaneous generation? Was this what he had in mind when he lamented the immaturity of the early versions of the Bildungstriebesse? The second question, which is systematic, concerns what we should conclude in the end about the relationship between the formative drive and spontaneous generation. Was Blumenbach mistaken to see the two as closely related? Does Blumenbach's theory, in fact, depend on the viability of a theory of spontaneous generation? We will take up the first, namely the historical question first. I cannot offer a definitive explanation, but the textual record is nonetheless suggestive. As noted above, Spallanzani and Bonnet's attacks on spontaneous generation had Needham on the ropes, and the fortunes of spontaneous generation were not good. Blumenbach confirms this in his own introduction of the concept in both the Handbuch and the Bildungstriebesse. During the time between the publication of the second edition of the Handbuch in 1782, which is the final time I know of where Blumenbach endorses the existence of spontaneous generation in print, and his decision to publish a new version of the Bildungstriebesse in February of 1787, which was eventually published, of course, in 1789, he appears to be especially aware of the work of both Bonnet and Spallanzani. Blumenbach visited Bonnet in Geneva in October 1783 and began a correspondence with him the following month, which lasted until the middle of 1787. They discussed a great many things, including warmth in animals, the structure of the optic nerve, regeneration, and the ideas of other natural historians, including Spallanzani. During the period of their correspondence, the third volume of German translations of Bonnet's writings on natural history appeared, and Blumenbach wrote a notice for the Göttingische Anzeigen. A couple of minor complaints make it clear Blumenbach read the volume carefully. Beyond commenting on the quality of the translation and editorial apparatus, Blumenbach mentions two things. First, that the book is supposed to provide support for a theory of pre-existent germs, and second, the translator helpfully notes that Bonnet's repetition of Spallanzani's experiments regarding spontaneous generation in broth produced varying results. Just a few months before writing that notice about Bonnet, Blumenbach received a letter from Friedrich Scholl in Switzerland. Scholl reported that he had just read Spallanzani's essay on digestion, which he found to be, quote, the most interesting work of physiology, unquote, and that he had heard of a new work by the same author on generation that, quote, should be exceptionally interesting, unquote. The former work bears on Blumenbach's interest in the possible spontaneous generation of intestinal worms. Haller had argued that digestion involved a kind of partial putrefaction, a view which lent support to the notion that simple life forms could emerge spontaneously in the stomach or intestines of animals. Spallanzani's experiments on birds, and indeed on himself, showed this could not be the case, since the digestion of food by gastric fluid was complete before any putrefaction could begin. Thus, the hypothesis that digestive putrefaction might be the matrix for the spontaneous generation of intestinal worms was less attractive because of Spallanzani's work. I do not mean to say that Blumenbach was convinced that Spallanzani's experiments regarding either the development of animalcules in vials of broth or the process of digestion vindicated pre-existence theories. Quite the contrary. In his 1786 notice on the French translation of Spallanzani's book on generation, Blumenbach observes that, quote, in other circumstances, one would take this novel to be a satire of preformed germs, unquote. Regardless of whether Spallanzani and Bonnet could marshal their experiments to support preformed germs, they were effective at turning opinion against Needham, Buffon, and indeed anyone else defending spontaneous generation. That Blumenbach makes special mention of a German translator's doubts about the conclusiveness of these experiments suggests he was a bit desperate to push back against them. Moreover, the degree to which these experiments were occupying the attention of the reading public is illustrated by a 1785 review of a French translation of Spallanzani, which opens by noting that the book really needs no notice, since people already know these experiments and their implications. Regardless of whether these experiments undermine Blumenbach's claims that intestinal worms in very young and unborn animals or galls on rose bushes are best explained by spontaneous generation, Blumenbach would have seen that the popularity of the idea more generally was on the wane. I suggest, therefore, that the reason Blumenbach stopped tying the formative drive to the idea of spontaneous generation after 1782 was because his growing awareness of the momentum behind Bonnet and Spallanzani's attacks on the idea made it more of a liability than an asset in the promotion of his own epigenetic view. Whereas he might reasonably have thought that invoking a qualified version of spontaneous generation would be effective for both contesting prevailing pre-existence theories and highlighting the explanatory power of the formative drive in the early 1780s, his calculation changed sometime in the following year. In the mid-1780s, in other words, he came to see spontaneous generation as a sinking ship that he and the formative drive would do well to abandon. From then on, he presents largely the same criticisms of pre-existence theories, now without mentioning spontaneous generation. Effectively, this allowed Blumenbach to parry Spallanzani's experimental attack on spontaneous generation without accepting his and Bonnet's claims regarding their broader significance in relation to generation theory. So that brings us finally to the systematic question of what the connection between Blumenbach's formative drive and spontaneous generation really is. Peter McLaughlin, for one, argues that spontaneous generation is essential to Blumenbach's conception of the formative drive. In McLaughlin's reconstruction, the formative drive is not part of a theory of generation, but a theory of the formation of organic life. That is, the formative drive does not explain how an egg is fertilized, for example, but how the egg forms itself, rather than merely unfolding or expanding itself after it attains a certain degree of organic life. Moreover, the formative drive is inherent to living things, but must be stimulated or aroused by a sufficient degree of organization that makes the living thing, quote, ripe for genuine epigenetic formation. Quote, it is important to emphasize, McLaughlin writes, that the formative drive is not produced by this process of ripening, but is activated by it. The transition from non-organic to organic, that is, spontaneous generation in the true sense, is a condition and cause of the activation of the formative drive that belongs to the vital powers from the beginning, unquote. Since every living being initially derives, according to epigenetic theories, from unorganized matter, which subsequently activates the formative power that comes to propel it further, McLaughlin concludes that, quote, one can even claim that every individual is spontaneously generated, unquote. In short, spontaneous generation is an at least implicit assumption of Blumenbach's theory of the formative drive on McLaughlin's view, insofar as epigenesis is at base a theory of how life emerges from matter itself, rather than from divine forms implanted in the world. If organic life did not first emerge within or from non-organic matter, the formative drive would never be activated. If this interpretation is correct, then Blumenbach's decision to forego explicit reference to spontaneous generation in his presentation of the formative drive after 1782 can only be strategic rather than substantive. That is, faced with mounting experimental evidence from both Bonnet and Spallanzani that spontaneous generation does not occur in the ways Needham, for example, described, Blumenbach decoupled it from his public presentation of the formative drive. Despite this rhetorical change, the real dependence of the formative drive on the spontaneous generation of life from unorganized matter remains. As I've already said, I agree with the claim that Blumenbach was led to abandon references to spontaneous generation by the growing consensus in the mid-1780s that spontaneous generation was indeed illusory. I disagree, however, with McLaughlin's characterization of the connection between the formative drive and spontaneous generation. And this disagreement is motivated by his understanding, that is McLaughlin's understanding, of the idea of spontaneous generation itself. On McLaughlin's account, spontaneous generation in the true sense occurs in the transition from the non-organic to the organic. While this explanation has an intuitive appeal, it is out of step with Blumenbach's own discussions of the idea. That is, when Blumenbach discusses spontaneous generation, he focuses on surprising or puzzling phenomena like rose galls or worms in the intestines of unborn animals, not the first origins of any and every living being. Thus, even if McLaughlin is right that spontaneous generation is an implicit assumption of Blumenbach's conception of the formative drive, this is still sufficiently removed from the explicit content of the relevant texts that it cannot shed light on the question I have focused on here, namely, what is the conceptual or systematic significance of the changing presentation of the relation between these two concepts? It seems to me, however, that McLaughlin is mistaken that the formative drive implicitly assumes the reality of spontaneous generation, because his understanding of spontaneous generation renders the phenomenon entirely too ordinary. If the purest form of the idea is the transition of some lump of matter from a non-organic to an organic state, as he claims, then every instance of nourishment, which appropriates foreign material into the body for the sake of the maintenance and expansion of its already existing organic structures, amounts to spontaneous generation. Not only is such a view far from Blumenbach's own discussions of the ideas, it is distinct from any conception of the matter I am familiar with. I think we should instead conclude that there is no systematic connection between the formative drive and spontaneous generation. There is a kind of family resemblance between the two ideas, insofar as they each ascribe capacities to matter itself that other views reserve for God. That is likely part of the reason Blumenbach appeals to the concept in 1780. More than that, if real, spontaneous generation would offer decisive evidence against pre-existence theories. But the latter is Blumenbach's real target, and he is happy to draw on a wide range of phenomena, at least some of which he came to regret later in his criticisms of it. When he comes to see one element of his account as distracting or lacking in some way, as he did with the proto-Lamarckian examples of inherited adaptations included in the early versions of the Bildungstrieb essay, he leaves them behind and shifts the focus elsewhere in later texts. This, I believe, is how we should understand his early insistence and later silence on the relationship between spontaneous generation and the Bildungstrieb. Thank you for your attention.